The installation of any underground piping material is truly a task the engineer, installer, inspector, and owner want to do only once, and they want to do it correctly. Consider the saying, "Out of sight and out of mind" is true of most we leave behind. This can only be accomplished if all those involved in the installation and design process understand proper installation and inspection requirements, as well as any limitations of the piping material involved. What sometimes appears to be a savings in material costs can result in a more expensive installation if the piping material is properly installed, and a defective piping system if the material is not properly installed. In recent years, thermoplastic sewer pipe has been viewed as a less expensive material used to replace cast iron soil pipe. Because thermoplastic sewer pipe lacks the rigidity and strength necessary to support expected earth loads and live loads, special installation requirements apply. An underground pipe is expected to support the earth load, expected live loads, and traffic loads, while limiting pipe deflections so obstructions to flow and joint leaks do not occur. Pipes for underground installation are generally classified in two ways. One is rigid, which includes cast iron, concrete, and vitrified clay. The second classification is flexible, which includes PVC, ABS, and steel. Rigid types are expected to support the anticipated earth and live loads with little or no deflection. These types of piping depend upon strength, rigidity, and stiffness to maintain their structural integrity. Flexible piping systems are designed to use the side fill stiffness of trench construction to limit the outward deflection as earth and live loads are exerted on the top of the pipe. There are 5 major differences in installation to consider between rigid and flexible piping in an underground installation. They are trench width, trench bottom, backfill compaction, deflection, and resistance to crush loads. First, consider trench width. With cast iron soil pipe, a rigid material, the trench can be as narrow as the installer needs to make the joint connections. Because of its strength and rigidity, no special requirements for trench width are needed to support the expected earth and live loads. Thermoplastic sewer pipe is a flexible material. As a flexible material, thermoplastic sewer pipe is dependent upon side fill stiffness to limit deflections. ASTM D2321-89 recommends a trench width of the pipe outside diameter plus 16 inches, or pipe outside diameter times 1.25 plus 12 inches. This increased width is necessary to allow hand compaction in the spaces between the trench walls and the pipe. This additional compaction is required to enhance the flexible material's sidewall stiffness and to limit deflection. With cast iron soil pipe, a rigid material, the trench bottom can be flat with hub or coupling holes provided so the pipe is uniformly supported. No special bedding is necessary unless the pipe is to be installed in rock excavations. With thermoplastic sewer pipe, however, the trench bottom must be provided with a minimum of 4 inches of bedding unless otherwise specified by the design engineer. This bedding material varies by soil type. ASTM D2321-89 provides a classification chart for determining which type of bedding to use for a particular condition. This classification can be both confusing and difficult to use. Once an underground pipe is installed and inspected, it must be backfilled. With cast iron, no special compaction of the backfill is necessary, except for meeting the normal compaction requirements of the excavated area. Since cast iron is a rigid material, it does not depend on side fill support, although sometimes installers may use a small amount of granular fill to improve the grade. On the other hand, flexible thermoplastic sewer pipe is dependent upon side fill support to control deflections within acceptable limits. This deflection should be verified using an approved test method to determine that the pipe has not exceeded the maximum 5% deflection. Compaction in 6-inch maximum layers is required to the spring line of the pipe. Compaction around the pipe must be done by hand and rigidly controlled. As we noted earlier, the trench width must be wide enough to allow for this compaction. Depending on the type of soil, a minimum density compaction can range from 85% to 95%. If the installation does not have suitable backfill available that can be compacted, it must be brought in from another source. Measurement of this critical compaction is not easily accomplished. Deflection in all piping materials must be controlled to prevent flow obstruction and assure that joints remain secure when earth and traffic loads upon the buried pipe occur. Cast iron is, of course, rigid, so deflection of the pipe wall is almost non-existent. This is not the case with thermoplastic pipe. Lack of adequate backfill compaction to the spring line of the pipe can result in extensive deflection, since the compaction must help support the vertical loads put on the pipe. If deflection of the thermoplastic piping exceeds 5%, the pipe does not meet specification and has failed. Excessive deflection will result in infiltration of groundwater, overloading wastewater treatment plants, and exfiltration, contaminating the groundwater and soil. Another important consideration in underground piping installations is resistance to crush loads. Before selecting and installing piping materials, expected loads and crush values must be determined. Cast iron pipe has a known crush strength, and once expected and live loads are determined, crush values are easy to calculate. The specifier can then easily select the proper size of cast iron pipe and know the safety margin. Thermoplastic pipe is dependent on side fill support to supply the added stiffness required to resist the earth and live loads. This chart demonstrates the resistance to crush loads between 10-inch cast iron pipe and 10-inch Schedule 40 PVC pipe. ASTM 2665 requires that 10-inch Schedule 40 PVC pipe should not be deflected more than 5% at 503 pounds per linear foot to be within specification. But in the case of cast iron, the minimum ring crushing load on 10-inch service is 4,342 pounds per linear foot, over 2 tons. Cast iron is 8 times stronger than its plastic counterpart, without relying on any compacted backfill or side fill support. In the case of thermoplastics, with their lower stiffness values and ring deformation values, greater pipe stiffness can only be obtained by adjustments to trench width, backfill, side fill, and compaction. This increases both installation and inspection costs. This chart shows actual earth and live loads on thermoplastic piping buried 3 feet. For example, on 6-inch pipe buried 3 feet, earth loads of 465 pounds and live loads of 563 pounds would be exerted. However, looking at the pipe stiffness values and ring deformation values in the table, you will note that the plastic pipe is rated at 596 pounds per linear foot of pressure at 5% deflection. This means that theoretically, a thermoplastic piping material could meet the requirements of the specification at 596 pounds, but might not meet the total load on the pipe of 1,028 pounds. Again, adjustments to backfill and compaction are necessary for the plastic pipe to carry the combined weight of the earth load and live loads. Cast iron requires no additional support. Cast iron offers the greatest margin of safety for the owner, architect, engineer, and inspector. And remember, most of today's cast iron systems are joined by compression joints or hubless couplings, which make the installation just as easy as plastic. The installation requirements for backfill and support for cast iron are minimal when compared to those required for thermoplastics to perform reliably. Cast iron is often less expensive to purchase and properly install in both the long run and the short run. Your reputation, budget, and project will be enhanced by specifying cast iron soil pipe for underground installations.